So, hopefully you have your learning target written down. Oh, zoomed in super far. I can graph a square root function. That is what we are going to be doing today. Mitchell, I've already asked once for phones to go away. Please put it away.
It doesn't even work.
Don't care. Didn't ask for anything from the peanut gallery. Just wanted it away.
Oh!
And exhibit A of why we can't have nice things. Alright, so what we're going to start with today is f of x equals the square root of x. So we are going to be graphing this, and this is our parent function. This is the beginning function, the alpha and the omega of square root functions. And we can do other things to it, just like we did quadratics, where our parent function was x squared. But we're going to learn how to graph the base one first. Now, your homework last night, that worksheet, was to take the square root of these numbers. And when you use, like when you take the square root of 12, you got a decimal, right? And when you take the square root of 8, you got a decimal, unless you simplified it. So what we're going to be doing today, instead of graphing decimals, we're only going to plug in perfect squares into x. Can you put that down and pay attention? Because we're having class. Thank you. Alright, so we are only going to plug in perfect squares for x. Everybody write that down. Plug in perfect squares for x. Ah. Now remember, it's just like what we did before where we plugged in x values and got our y values. But this time, we're plugging in specific numbers. So our first perfect square is 0, because if you take the square root of 0, you get 0. Then we're going to plug in 1, 4, and 9. Those are our perfect squares. Does everybody understand? Now, why are we plugging in perfect squares? I just explained it.
We gotta get x.
No, these are x. Why are we plugging in perfect squares?
We said plug in perfect squares for x.
These are x. Why are we plugging in perfect squares? Because it's easier to square root. Because if you take the square root of something that's not a perfect square, you're going to get a decimal, and I don't want to graph decimals. Are you ready? Alright, let's plug in 0. What's the square root of 0?
0.
Alright, let's plug in 1. What's the square root of 1? Let's plug in 4. What's the square root of 4?
2.
Let's plug in 9.
3.
And then you just plot it. That's it. That's all you have to do to graph these. It's so easy.
Wow.
These are the easiest things we graph, other than lines. And I don't know if some of you can do that yet. Alright, so draw your table like this. Now, last week when we did the quadratic formula, we talked about when we take the square root of a negative number. Can we take the square root of a negative number? No. So you will not plug in a negative value for x unless there is something else under the radical. Does everybody understand? If there is something else under the radical, then we would plug in a negative value. And I'll show you that situation in a minute. Alright, let's plot this. 0, 0. You put a dot here. Where is 1, 1?
Right 1 up 1.
Alright, where's 4, 2?
Right 4 up 2.
And where's 9, 3?
Right 9 up 3, 7, 3.
It's not a competition. Okay, maybe you should compete with your grade then. And that's it. That's all you do. Now, we don't go any further than this point because we can't plug in negative numbers. And boom, we're done.
Are we always going to do our graph like that?
Yep.
So it's always going to be 0, 1, 4, 9.
You will always plug in those x values unless there is something else under here.
Okay.
Now, let's talk about our domain. The domain is x values. And it says x when x is greater than or equal to 0. Did we plug anything less than 0 into our x value? So that's why it's greater than. Now our y values, did we go below the x-axis? So it's y when y is greater than or equal to 0. That's all you have to do. Now, this vertex form looks a lot like our quadratic vertex form. You guys remember when we had the parentheses and the squared on the outside? It's the same thing, where your vertex is the opposite of whatever this is in K. This is your starting point. This is where you begin your graph. And then from there, do you guys remember when we had vertex form, we went up the perfect squares, then left or right the counting numbers? This time, you're going to go right the perfect squares, and then up the counting numbers. So it's the opposite. You go right the perfect squares. So we went right 1, up 1, right 4, up 2, right 9, up 3. If we wanted to keep going, we would go right 16, up 4. So you just plot your vertex and then use your points. You don't even have to plug anything into a table. We're going to practice both ways, though. Now, the reason that our vertex is 0, 0 here is because we don't have an H and we don't have a K. So if we don't have anything here, our vertex is 0, 0. Can you wait and let me finish explaining? Does everybody understand? Are you sure? Do you understand that 0, 0 is the starting point because we have nothing here and here?
Yes.
Fantastic. Now, what did A do on a quadratic, that number out front? When it was positive, what did it do? When it was a... Because you said one thing and was wrong? Okay. When it's a positive, what did it do? It went up. It made a taco, right? And when it was negative, what did it do? It made a snow cone. So this time... No, you said if it was a positive, it made it negative.
Exactly. It would do the opposite.
Would.
Alright.
No. So if this number is positive, it's going to look like this. Now, I don't have a food reference for what that could possibly look like.
A pizza.
That doesn't look like a pizza,
No,
you
those
weirdo.
are pepperoni.
What type of pizza do you eat?
Right. And what kind of pepperonis do you have that they look like that?
It's a spaghetti noodle with Parmesan cheese stuck on it.
Yep.
No.
It's a strain of
No.
beer with little lice eggs.
But guys, if it was negative, it would look like this. So that looks like what is wrong with you people?
No. It's a football field.
No,
What?
set up on one.
People.
That's 5 push-ups.
Wow.
Oh,
You don't think what?
No, all the time you.
Do your 5 push-ups.
Right. You said S up, so you have to do your 5 push-ups.
Oh, okay.
Get down and get up.
Wait a minute.
Gotta get up.
Does anybody have any questions on this before we go any further?
Oh, shit.
Yep.
Check your. See, you say shake your mouth. Can you say that?
Do you see this face? This is not my happy face.
Can you say shake?
Do your push-ups.
You should go ahead and give them.
The rest of you turn your paper over and write 56B.
Where are you going? You see how much?
Just let him.
1, 2, 3, 4. Oh. Okay.
Alright, graph each function. Let's do this. Our first one that we are going to graph is, I'm going to show you what happens if we add something to the outside of the radical. Not the inside of the radical. So that's f of x equals the square root of x plus 30. And we're going to learn what happens when we do that. What do you think it's going to do? The plus 3. Why do you think it's going to turn into a negative? I just want to know why. It's not absolute value. And that would turn into a positive.
Are you gonna square it?
Nope. What do you think the 3 is going to do?
Go up.
Go up how many?
3.
Look at you guys go. Alright, now we are going to create a table. And we're going to use our table first, and then I'm going to show you how to graph it using vertex form. Alright, what numbers did I just get out of my mouth and tell you that we're going to use when we're making a table?
0, 1, 4, 9.
Yes, because we use the perfect squares. Because 2 is not a perfect square.
How is 2 not a perfect square?
Because the square root of 2 is 1.14.
Oh.
Boom, in front of your mom on Christmas. Let's do this. Alright, let's plug in 0. What is the square root of 0?
0.
Plus 3 is
3.
magic.
Oh.
Oh my god.
Alright, let's plug in 1. What's the square root of 1?
1.
And what's 1 plus 3?
4.
Wait, what?
We're just plugging in, let me do it. We're plugging in numbers. The square root of 1 is 1. 1 plus 3 is 4.
Where
The square root is, where did I get what?
Where did you get that from?
Which one?
The 3.
It's part of my problem.
Miss Asbury, can we have Christian Solito to check out?
Yes.
Okay.
No, I'm talking about the 3 on the Y.
Right here?
Yeah.
Because the square root of 0 is 0. 0 plus 3 is 3.
Okay, then where do you get the 4 from?
Ooh.
Because the square root of 1 is 1 and 1 plus 3 is 4.
Wait. I'm confused.
Okay. This x value, we take and put right here.
Okay.
So we take the square root of 1, which is 1.
Okay, yeah.
And then 1 plus 3, I have 1 apple, and then I add 3 more apples, and I get 4 apples. And I'm happy because I got 4 apples.
Wealthy.
Bye, see you tomorrow. Alright, now I'll plug in 4. What's the square root of 4?
5. Oh, snap.
2, and 2 plus 3 is? So how many apples do I have now? Man. Now I'll plug in 9. What's the square root of 9? What's 3 plus 3? How many apples do I have? Magic.
I get it now. Hey, shake shirt.
Trap.
Trap now. Wow.
Alright, so please draw your x and y axis. We ready?
No.
Are you going to copy this down, or are you
Yes.
just chilling?
Just chilling.
I look like it's like
You sure it's all the way on the side?
Just chilling. Cedar.
Because you've never stolen a pen out of there before to write your notes.
I didn't steal it because I returned it.
Alright, so let's start by plotting 0, 3. So you don't go left to right any, but you go up 1, 2, 3. And then, yes,
I'm interrupting. I'm sorry.
it's fine. What is it?
It doesn't, like, we don't have a graph to graph and all. We don't have a graph to graph.
Did you not make a graph?
No, I made, like, the lines to the X and Y.
That's a graph.
Oh, goodness gracious. What a day.
It's the
Alright, then we go right 1, up 1, 2, 3, 4. Then we go right 4, up 1, 2, 3, 4, 5.
Miss Asbury, what if you don't have any lines like that?
Just count up, man. You just count up.
It makes another pizza.
Wait, how far did you go? 4, 5, 4.
I'm scared because you don't look the same as your graph.
It's okay.
It's
I will-
look completely identical. It's
Right.
Not a magician of some sort.
And I am.
Did you go to Hogwarts?
Yep.
It's a pizza. Don't worry about you. Again.
Yeah, mine looks nothing like
It's okay. Just connect the dots.
It's terrifying.
For the love of God, connect the
what
dots.
is look at that.
Then you did something wrong. You didn't go over. You didn't go over. Go right 4.
Oh.
And then the bottom one's 9.
Yeah, I didn't do 9. Obviously.
Okay, now, what is the domain for this function? Remember, domain are the x values. So what are the x values?
0, comma 1, comma 4, comma 9.
So it's x when x is what?
0, comma 1.
Is a greater than 0, less than 0, greater than 1, less than 1? What is it?
0 is greater or
Greater than or equal to 0. So that's how you write it. because we didn't go below 0 because you can't plug in negative values into this. Does everybody understand?
Yes.
Are we sure?
No.
Okay, what part don't you
I
understand?
don't understand how to
Yes.
Okay, domain are your x values. The x values are all greater than or equal to 0 because can we plug in any negative values?
No.
No, because you can't take the square root of a negative number.
Okay, I got it.
So that's why it's greater than or equal to 0 because you can plug in 0. Now your range, did our y values move up from the parent function? They did. So what's it greater than or equal to this time?
It's 3.
3, yes, because that's our smallest y value. That's all you have to do. Now, if I wanted to graph this using vertex form and not plug in my table, what I would do is I would look for my h. There is no number under the radical, so my h is 0, and then it's plus 3, so it goes up 3. And I would put a dot here. And then on the front of our paper, we said we would go right our perfect squares and up the counting numbers. So from here, I would go right 1, up 1, right 4, up 2, right 9, up 3. And that's exactly what we did. Yes.
Everyone's going to be 0, 1, 4, 9 though, right?
Unless there's something under here, you will always use those. And I'm about to show you what happens with that.
Okay.
That's our next problem, actually, so that you can, we're going to graph it using vertex form by plotting our vertex and then using our perfect squares, and then we're going to talk about what x values we plug in. So B says f at x equals the square root of x minus 2. Now, A was the square root of x plus 3. This is the square root of x minus 2. They're two different things, so make sure you're saying it right. What we're going to do first is we're going to find our vertex. What is our vertex? Well, it's HK, right? And it's the opposite of whatever this is and the number out here. So what's our vertex going to be? Positive 2, 0. Because there's no number out here, so that's my vertex. Does everybody understand? Yes. Okay? We take the opposite of whatever number is in here, and then if there's any number out here, is there a number on the outside of the radical? So the y value is 0. We take the opposite of negative 2, which is? Yep. Did you just ask me if this is a new problem? We were on A, and now we're on B. All right, let's draw our graph. So we're going to do the table in a minute, but what I want us to do first is the vertex form. Are we ready?
Yeah.
I thought you took 2 over there, but you like last time you did like 0, 1, 4.
I'm not making a T-table.
Oh.
Wait, didn't you already get the vertex? So if you get the vertex, you got the vertex, and then you do the square.
Yes, that's what I'm about to show you. I was just waiting on y'all to finish drawing your X and Y lines, which takes 47 years. Alright, so let's plot this. Let's go right 2, and then we don't go up or down any. Now, from vertex form, you go right the perfect square. So we're going to go right 1, 4, 9, and then we're going to go up 1, 2, 3. So from here, we're going to go right 1, up 1, put a dot. Then what am I going to do? Right 4, up how many?
2.
Yep, up 2. The square root of 4, yep. And then what do I do from there?
Right, not really.
And then boom, you're done.
Another pizza. All day.
Oh, yeah, so
It's not. Ambidextrous means that you can use both hands to write.
Dude, I wish I was like that, really.
I wish that you would just use both sides of your brain, but here we are.
All
Alright, now let's talk about how we would use a table. Now, we can't use 0, 1, 4 because we need to get perfect squares under the radical. If we use 0, 0 minus 2 would be negative 2. Can we take the square root of negative 2? No. So you have to be careful of what you plug in. You can only plug in numbers that are to the right of your vertex. So if I wanted to get 0 under the radical, what number minus 2 is going to give me 0? So I start with 2. Then I want to get 1 under the radical. What number minus 2 will give me 1? 3. Then I want to get 4 under the radical. What number minus 2 will give me 4?
6.
And then I want to get 9 under the radical. What number minus 2 will give me 9? 11. Then you just plug those in. 2 minus 2 is 0. The square root of 0 is 0. 3 minus 2 is 1. The square root of 1 is? 6 minus 2 is 4. The square root of 4 is?
Oh, I see where they're going with this.
Congratulations. 11 minus 2 is 9. And what's the square root of 9? 3. So that's why when it's under the radical, you have to be careful of what you plug in. Does everybody understand? You have to move it. So sometimes it's easier to use vertex form. Sometimes it's easier to use a table. Now, what do you think is going to happen if I put a number on the outside of the radical? When we had a number out front of x squared, what did it do? If it was a whole number, what did it do to that parabola?
It made it
make it at 12
wider.
If it was a whole number, it made it steeper, right? Like this? Made it skinnier? And if it was a fraction, what did it do? It made it like this. What if it was a negative? What would it do? Like that. Can't really do that. So what we're going to do now is we're going to see if that holds true to doohickeys, square root. We're going to do I want to do that?
Sure.
Okay.
No, chill out.
Negative 1/2 times the square root of x. I was going to do a whole number, but Tariq said go ahead.
I'm confused already.
Is it yours? Because it's been chilling there for like a week. And I've been, I was going to have a new jacket soon.
Under Armour.
Okay, now, do you think with this fraction that it's going to make this steeper or is it going to make it flatter? Y'all think it's going to make it flatter? Who votes flatter? Who votes steeper? Okay, let's see what happens. Get excited. All right, let's use a... Okay, I get it. You're voting wider. Those were not the two choices.
Straight up.
Go get it.
Straight up.
Listen, Andrew, I swear to God, I just heard somebody say the B word, and I'm not playing. I'm God, I heard somebody say, like, he said,
Nobody cares.
Nobody
Nobody
said that.
It's so mad.
Nobody
Okay.
cares.
okay, because everyone said,
And you just said it again.
5 more.
okay.
So weird, man.
I said fudge.
I think we need to
Continue.
outside.
I think so. I think some of us need timeout, like we're 5, because we can't control ourselves, like we're 5.
I'm good.
So do your push-ups and get it together.
Time out while standing in
Where are you going?
That's right.
Do you need a timeout too?
You need time out.
Nobody's talking to you.
Okay, this time I have to sit on your back.
Alright, 0. So if we take the square root of 0, what do we get? And what's 0 times negative 1/2?
Oh, 0.
Alright, so if we take the square root of 1, what's the square root of 1? And what's 1 times negative 1/2? Negative 1/2. Alright, if we take the square root of 4, what's the square root of 4? And what's 2 times negative 1/2?
6. Wait, no, negative 1.
I do not know.
Negative 1.
Uno.
Yeah, because 2 divided by 2 is 1. 1 times negative 1 is negative 1. Boom. Knowledge. I want to plug in 9, but I don't have enough room down here. So I'm going to write it over here. What's the square root of 9? And what's 3 times negative 1/2? Yes, negative 1.5. All right, if I plug in 16, let's go crazy. What's the square root of 16? And what's 4 times negative 1/2? All right. Now, some of us said steeper, as in going up, and some of us said flatter. So let's see what happens. You think flatter? All right, so it's still at 0, 0, right? And then 1, and then negative 1/2. So go halfway between 0 and 1. 4, negative 1. 9, negative 1.5. 1, 2, 3, 4, 5, 6, 7, 8, 9. Down 1 and then a half. And then 16 is negative 2. So did it get flatter or steeper? It got flatter.
Told y'all.
So it does the opposite of what it did with parabolas, right? Now let's talk about domain and range. No. We got flatter. Closer to the x-axis.
Why do you say flatter?
Because it was like this, where it went up more, and now it's closer to the x-axis. See the difference between these two?
But why can't it be get flipped?
What?
It doesn't flip.
It's flipped from this because it's negative. That number out front was negative, so it made it go upside down.
Right there. Like exactly. So it's flipped now.
But it's flipped over and flatter. It's closer to the x-axis than this one is.
Okay, I'm sorry.
That's okay. That's why. All right, your domain. Now, did we plug in any x values less than 0? You plugged in x values less than 0?
No.
So it's x when x is what? Greater than or equal to 0. All right, our range. Did we get any y values less than 0? Did we get any y values greater than 0? Nope. So it's y when y is less than or equal to 0. I'm sorry? 0.
2.
All right, let's look at our domain and range of B. Our domain, our x values, did they change this time? Our x values, did we shift? We changed. And did we get smaller than 2?
No.
Because it would have become a negative. 1 minus 2 is negative 1, so that wouldn't work. So it's x when x is greater than or equal to 2. Now, you need to understand how to do this because that's part of your homework tonight.
Okay. So you need to just figure out the domain.
You have to graph and figure out the domain and range. The domain cannot be anything less than what your smallest x value is. Your range cannot be anything less than what your smallest y value is. So what is y greater than or equal to? 0. Now you're going to need 8 colors for this next activity. 8 colors. Yes, you may.
This has right here.
Those are my color pencils, so if you want to use my color pencils, maybe.
All right, now what I want you to do is I want you to take your 8 colors and we're going to go over the arches. No. So we're doing it right now together. Sean? It does not have to be the same as mine.
High demand. Okay, don't touch me. I'll give a plate to your favorite pet.
Stop that.
Ella? I only have one.
Shaquem, stop.
Give those back when you finish.
Yeah.
I don't need them.
Yeah.
One more. Fire it over.
Can I get a sheet like that?
I'll put some.
Let's add basically color the lines with different colors.
Yes, that is what I'm doing. I'm coloring the lines different colors. And the reason is because we're going to match the equations to the lines up there, and we can't do that unless they're different colors.
Every single line is a different color.
Yes, that's why we have 8 colors and 8 lines.
Fair.
So every single piece has a different color.
I've already used this.
I'm trying to hand you one, but you're taking 75 years.
Is that right? Is that correct?
Can I have them back so I can label mine correctly? Tyreek, do not confuse my markers with other markers, okay? Because they go back in that roll up in a specific order. Do you understand? I'm not playing with you. Like, I'm going to hunt you down for some markers.
I don't know the specific order, but I know
I don't need you to know the Pacific order. I just need you to know which ones are mine, baby. That's all I need you.
Specific.
I just need you to know which ones are mine, okay? Thank you.
Specific.
Pacific Ocean. We just color in lines, folks. We're not curing cancer. Let's go.
Interruption, but we have several afternoons.
We're still working, even though she's talking, so let's do this.
It's been a couple of days, so you'll listen up.
Baby, hand me the markers.
Tomorrow, Wednesday, will be.
Please hand me the markers.
Drive
Well,
day.
lose it on
Look
you.
for your dream job. And remember, your checkout form will be
So-
due Friday.
Oh, I'm exactly Saturdays.
Checkout form.
Yes, I am. By a mile.
Sounds like a 59.5.
There will be basketball tryouts.
Yeah.
Boys basketball
I checked out your stuff.
I don't have any extra count here. Use this purple.
3:30 to 5:30 the main gym. This is for 7th through 11th grade students. Dr. Shear's group.
Here's green.
If you have signed up,
That's all we got. You have to use one again. We gotta go. Alright guys, so what we're gonna do is we're gonna match up the functions down here to the graphs up here. Now the first function is our parent function, y equals the square root of x. So on mine, which one do you think that is? Do you think it's this big red one?
auditorium. It's serious.
What about this skinny one?
Tonight, there'll be the talent show tonight at 10:30.
Remember the square root of x, it has to go through 0, 0. It has to go through 1, 1. It has to go through 4, 2, and 9, 3. So I think it's this green one right here. So the square root of x is my middle green one. So write a beside it and then color it whatever color yours is.
On the lookout for those, but not mistaken.
I'm confused already.
Okay, the square root of x, huh?
That is like right the word and the color.
Yeah, you right. Yes. Now, the square root of x, the graph of it is this one right here. This is our parent function. It has to pass through 0, 0, 1, 1, 4, 2, 9, 3, which that does, and 16, 4. That passes through it. Now, negative, what does negative do?
Congratulations, you are 2017-2018 freshman.
Flips it upside down. So which one is flipped upside down? The orange one.
Bye. 2:30
Is that like a
by
4-year-old?
Friday, and those who made it, your first meeting will be Tuesday, May 16th in room 233.
All right.
So the people who made it are Talia Williams,
Oh, yeah.
Micah Lake,
Yeah.
Abby Malco,
Yeah.
Grant Willis,
Yeah.
Sarah Hagan, Fung Kong, Aaron Unger,
Now, +5 under the radical, we know that moves it left or right. Now, when it's a -2, it moved it right too. So what would +5 do?
Chloe Sims, Madison
It would move it left 5. So it's the opposite. So it's that one.
Coxett,
It's the blue.
Yara Dollerson, and those are our freshmen.
That are.
Our officers are going to be
Now,
Madison Fincham,
minus-
President, Taylor Ezeko, Vice President, David Armstrong, Secretary, and Gabby Lazito, Treasurer. Congratulations to all of our new freshmen. We're looking forward to a great year.
-5 moves it right 5. So that's this
Thank you so
one.
much. Also, just wanted to remind everyone, just go a little further with exemptions. Okay, the last days.
Now, +5 on the outside. Remember that moved it up 5. So that's going to be this one up top.
For seniors, I'll start with seniors. The last day for attendance to be
It moved it
counted
up
towards
5.
exemption status
It goes up
will
5.
be next Monday. Okay, so absences.
So if +5 moves it up 5, what would -5 do?
Or exempting,
Down
it
5.
will be required and counted through next Monday, the 15th.
5 on the outside. So if a fraction made it flat,
11,
what would a whole number do?
Next Friday, the 19th. Okay, so I
Make
just
it
wanted to
steeper
clarify
up
that
high.
to you
That's
that,
G.
and
the last one is H. Oh, my
everyone
sweet
know
potatoes.
that, your attendance will be counted through those days. And so again, congratulations to our ambassadors and to the officers, and let's have a great afternoon. Thank you.
Okay. Oh, good. We still got like 7 minutes. Hallelujah.
What is
Miss
the
Asbury.
bottom one?
B,
Under D.
H. Yes.
You don't have focus on that.
Now, the next part, and what you're going to do, you have 2 parts for homework. You have to finish this where you tell me what happens and then answer the thing on the back. And then you have a worksheet where you're going to have to graph. Now, this says, describe how each variable transforms the parent function. So we're going to do A, H, and K together. Now, A, that's the number out front. What does A do? If it's positive, it means it goes up above the x-axis, right? If it's negative, what does it do? And if it's a whole number, what does it do? Makes it steep, right? And if it's a fraction, it makes it flat. So A controls the shape of it. Would you agree? So controls the shape of the graph. If A is greater than 0, it's up like this, and it's steep. If A is less than 0, it's underneath. And if A is a fraction, it's flat. Do we agree or disagree?
Agreed.
Now, what does H do, the one on the inside? Look back to what we found up there at the top. Look at C, where C is. C is x plus 5 on the inside, and it's this blue line. So what does H do? It changes where it starts, right? But does it move it left or right or up and down?
Up and down.
Left and right. So H moves the vertex left or right. So plus moves left. And what does minus do? Moves right. So A controls the shape. H moves it left or right. What does K do? The number on the outside. Find one that has the number on the outside and tell me what it does.
How far you go up?
What did this plus 5 do to it? It moved it up here, right?
Yeah.
So E. was up here. Plus 5 moves it up. Minus 5 moved it down here. So what does the plus on the outside do? What does K do? Moves it up or down. Alright, so this moves the vertex up or down. A plus moves up and a minus moves down. Now, you have to answer that tonight in your homework in paragraph form on the back. You have to describe it and explain it to me. Does everybody understand?
Oh my lord.
And you have 9 problems to graph.
Just as you just made this easy.
Well, I've given you the first part of how you explain it, right? So all you have to do is put those words into paragraph form.
How you doing?
Good.
Hey, okay, man.
Huh? Good.
You want to practice?
Huh?
If you have
You wanna
extras
practice?
of any of the foldable,
On this one?
please let me know.
What? On this one?
Friday. Nova Test Friday.
I ain't gonna practice. You know what?
What? I ain't gonna play this. You? I'll get my permit.
Test is on your hold up.
You got it? There you go.
Well, we have my binder that you can come in here and get it in order. 1 through 9. I need you to put my highlighters and stuff back. And then you can go. So, alright, 1 through 9 tonight for homework. And you've got 3 minutes, so do not line up at the door. Just sit down.